In this video we will analyze this graph of two trigonometric functions, two periodic functions. This is the legend up here. F of x is the dotted one and g of x is the solid one. And we will analyze it through the lens of a couple of questions over here. So for example, number 13, the equation for the graph of g of x could be all of the following except which one? Alright, so g of x, so we are only looking at the solid graph for this question. Alright, the main thing that's different between these is the phase shift. And then some of these have a positive a value, and then some have a negative a value. But let's focus on the phase shift first. All of these are a phase shift to the right. So this first one is a phase shift to the right pi. And then it has the positive a value. So this would be a graph that starts at pi and has a beginning that goes up first because it's a positive a value. So let's see if that's what's happening. Okay, so again, looking at just the solid one, here we are at pi and it starts at pi, and then from there we could look at it as going up first and then down. Okay, so this is looking good for A. So we're looking for the one that doesn't work. So so far A worked. Now looking at the next one, this one has a phase shift of 3 pi over 2. So we're looking for it to begin at 3 pi over 2, and because of the negative a value from 3 pi over 2, it should go down first and then up. So let's see if that's what's happening. So let me erase my previous markage. So here we are at 3 pi over 2, and then from there it goes down first and then up, just like we expected. So B is okay. So B is not the answer. Alright, so let's move on to C. C has a phase shift of pi over 2 to the right. So that means I'm expecting the graph to start at pi over 2. This is a positive phase shift, a positive a value. So from pi over 2 we'd expect it to go up and then down and back. So let's see if that's what's happening. Okay, erasing my previous markage. Alright, here we are at pi over 2. Wait a minute. This goes down and then up and back. Whereas we were looking for this to go up and then down. Okay, because it has that positive a value. So this is not working. That means C is going to be the answer to this question. Let's just follow through and look at D and see how D works out just fine. For D, the phase shift is positive 5 pi over 2. So we'd be looking for it to begin at 5 pi over 2. And then because of the negative a value, we would expect it to drop down first and then up. Okay, so let's just take a quick look one more time. So here we are at positive 5 pi over 2, and from there it does go down first and then up, and presumably. Okay, so they all worked as expected except for C. So C is the answer to number 13. Alright, let's move on to number 14. Which statement compares the two functions? Alright, and these questions seem to go on to talk about the amplitude and the period of each function. So let's just take a look at the image and decide what is the amplitude and the period for each function. Let's start with function f, the dotted one. So the amplitude for function f is going to be 1. You can see how it goes up 1 from the midline and down 1 below the midline, so the amplitude is 1. What about the period? Well, looking at one period of the function, it starts here at 0, and it goes up and down and back, and so it takes 2 pi to complete the cycle. So the period for function f is 2 pi. Now let's do the same thing for function g. First of all, the amplitude. Okay, for function g, it goes up 3 and down 3. So the amplitude is 3. And then the period. So it starts here at 0, it goes up and then down and back, and it completes a full cycle by the time it gets to pi. So the period is pi. So now let's look at each one of these questions. Okay, function f has a greater amplitude. Let's just start there. Function f has amplitude 1 as opposed to amplitude 3 for function g. So function f has the greater amplitude? No, that's false. So we know that A is not the answer. B, f of x has the greater amplitude. Yeah, again, we already saw that that's false, so I don't even have to read further. So B is not going to be it. Now, C, g of x has the greater amplitude. Okay, so far so good. G of x does have the greater amplitude. What else? And f of x has the shorter period. Well, f of x has a period of pi over 2 pi, whereas g of x has a period of only pi. So f of x does not have a shorter period. Alright, so C is not going to be the answer. F of x has a shorter period, false. So it must be this last one. G of x has a greater amplitude, and f of x has the longer period. That is going to be the answer. Alright, so the answer is D. Alright, now let's compare these functions just based on the equations that were given. Which function has the shorter period? Okay, well, let's just go through and calculate the period in each case. For this first one, the period is always going to be the normal period divided by the b value. So for this first one, it's going to be 2 pi is the normal period divided by the b value, which is 1/4. So when you divide by a fraction, you multiply by the reciprocal. So this would be 2 pi times 4. So this period would be 8 pi. Okay, so far we have 8 pi. Okay, now the next one. So here the b value is 4. And cosine also has a normal period of 2 pi. So 2 pi divided by the b value. Okay, and this reduces to pi over 2. So this one has a period of pi over 2. So far B is winning. We know that A is definitely not the answer. Alright, we want the shortest period, but let's keep going. Okay, now we're back to the sine function. So the period is going to be 2 pi divided by the b value. So that's just going to be pi. Alright, that is not shorter than pi over 2, so C is not going to be the answer. Alright, so far B is still winning. Okay, and now for this one, the normal period for tangent is pi. Now the b value is 1. So this function will simply have a period of pi. Okay, so pi over 2 is the shortest. So the answer to number 15 is going to be B.